In 1972, two strangers met for tea at Princeton. One was a physicist who studied the chaotic nuclei of uranium atoms. The other was a mathematician obsessed with prime numbers. They had nothing in common. By the end of that conversation, they had stumbled onto the strangest secret in all of physics, a hidden pattern that connects the structure of atoms to the rhythm of prime numbers, a pattern that should not exist. And here is the part that keeps physicists awake at night. More than 50 years later, nobody can actually prove why it is there. This is physics' biggest mystery, and it might be the deepest unsolved problem in the universe. To understand what they found, you need to know about two completely separate worlds. In world 1, you have prime numbers, 2, 3, 5, 7, 11, 13. The building blocks of arithmetic. They are scattered along the number line in a way that looks completely random. There is no formula that predicts the next one. For 2,000 years, the smartest people on Earth have stared at these numbers and felt the same thing. There has to be a prime numbers pattern hiding underneath. They just could not find it. In world 2, you have something called the Riemann zeta function. In 1859, a German mathematician named Bernhard Riemann discovered that this strange function has special points where its value drops to 0. He calculated a few of them. They all sat on a single straight line in the complex plane. And then he wrote down a sentence that has haunted mathematics ever since. I conjecture that all of them sit on this line. He could not prove it. He died at 39. For over a century and a half, nobody else could prove it either. The Riemann Hypothesis became the most famous of all the unsolved problems in physics and mathematics. The Clay Institute put a $1 million bounty on it, making it one of the Millennium Prize problems. And here is the kicker, those zeros, those tiny dots on the critical line, secretly control the distribution of every single prime number. Solve it, and you crack open the deepest secret of arithmetic itself. Now, fast forward to that afternoon in 1972. The mathematician was Hugh Montgomery. He had spent months studying the spacing between Riemann's zeros, how far apart they sit on that critical line. He had a formula. He did not know what it meant. The physicist was Riemann Dyson. He was one of the great minds of the 20th century, and in his free time, he had built an entire framework called random matrix theory, a way to describe the energy levels inside the nucleus of heavy atoms like uranium. Atoms so complicated that you cannot solve them directly, so you treat them statistically. You write down arrays of random numbers and study how their values cluster. This is the foundation of an entire field called quantum chaos. Montgomery was nervous about meeting Dyson. He almost did not go. But over tea, Dyson asked him what he was working on. Montgomery scribbled his formula on the blackboard. Dyson's eyes went wide. He recognized that formula. He had written it himself, years earlier, to describe how energy levels repel each other inside a uranium nucleus. The exact same equation, to the decimal. The Montgomery-Dyson moment had just happened, and physics would never look at prime numbers the same way again. Think about how insane this is. Prime numbers, pure, abstract mathematical objects that have nothing to do with physics, are arranged in a way that perfectly mirrors the energy levels of heavy atomic nuclei. The way a uranium atom shakes when you hit it with a neutron encodes the same hidden rhythm as the gaps between primes. In 1979, a mathematician named Andrew Odlyzko ran the comparison on a computer. He calculated billions of zeros. He compared their statistics to the energy spectra of real physical atoms. The match was nearly perfect. This is now called the Montgomery-Odlyzko law. And every time someone runs it on more zeros, the agreement gets tighter. So here is what we know. There is a hidden mathematical structure. It governs prime numbers. It also governs the quantum chaos inside atomic nuclei. The same structure, in two completely different worlds. Nobody knows why. This is where it gets uncomfortable for physicists. There is an old idea called the Hilbert Polya conjecture. It says the reason for this match is simple. Somewhere out there exists a quantum system, a real physical system, whose energy levels are exactly the Riemann zeros. If you could find that system, build it, and measure it, then the Riemann hypothesis would be proven automatically. Because energy levels in a real quantum system are always real numbers. They cannot drift off the line. They have to lie on it. In other words, the proof of the most famous problem in mathematics might not be a proof. It might be a particle, a vibration, a piece of physics we have not discovered yet. Physicists have been hunting for that system since the 1950s. They have tried random matrices. They have tried something called PT symmetric Hamiltonians. They have even tried black holes. A paper from 2025 linked the Riemann zeta function to the gravitational equations of black hole horizons. Each time they get tantalizingly close. The math lines up, the pattern matches. But nobody can write down the actual physical system. Nobody can build it. Nobody can prove it. And this is the part that should disturb you. If the Hilbert Polya conjecture is right, then the universe is doing something genuinely strange. The same hidden order that decides whether a number is prime is also deciding how electrons arrange themselves inside an atom. The number theorists and the physicists have been studying the same object from opposite sides, and neither of them realized it for 2 centuries. This is what people mean when they talk about the unreasonable effectiveness of mathematics. Mathematics should not know about uranium. Uranium should not know about prime numbers. But somehow they speak the same language. If we ever solve this, it will not just win someone $1 million. It will tell us something terrifying and beautiful about reality. That the abstract patterns of pure mathematics are not invented by us. They are written into the physical world, and we are just slowly waking up to what was always there. Until then, the pattern sits quietly on the critical line, verified by 10 trillion zeros, backed by 60 years of physics, whispered about over tea at Princeton, the deepest secret in physics, and the one nobody can actually prove. If this kind of physics keeps you up at night, you know what to do. Hit subscribe. The universe is hiding more of these, and we are going to find them together.